Hey everybody, this is Bodechon here. So today we're talking about molecular geometry, and really what we're just talking about is the shape of our molecules. So how do they get their shape? Well, we're going to think about opposites attracting and like repelling. So our electrons are always going to try to get as far away from each other as possible, and we're going to start to develop angles because of this, and that forms shapes. There's also lone pairs, which cause a little bend to happen in our molecule, and then we have shapes out of those bends. So let me show you what the lone pairs look like. So first of all, a lone pair is any pair of valence electrons that are not shared with another atom in a covalent bond. And you can see we have some examples here. This circled portion is our lone pair. So you can see we have single bonds, and then we have this pair that is not bonded with anything, therefore that is our lone pair. And you can see we have 2 lone pairs in B, and then we have 3 lone pairs in C. So now you can recognize what they look like. Now, we do have a difference between polar and nonpolar shapes as well. So our nonpolar molecules are going to be very symmetrical, meaning that all sides around the center of the atom are going to be identical, kind of like this one right here that you're seeing. So they're bonded to the same elements with no lone pairs of electrons. And then we have our polar molecules, and these are going to be asymmetrical. In other words, they're not looking the same on all sides of our molecule. And we're going to have sides that are partially negative and sides that are partially positive, like this one right here. So we're going to talk about 5 different shapes today in this video. Here they are, and let's talk about each one individually now. So we're going to start with the easiest one, which is linear. Notice it does look like a line, so it's linear, right? We can recognize this because it has 2 bonded pairs. So here is one bond, and here is the second bond. Now, the white dots are going to be representative of our electrons being pushed in the opposite direction, okay? So we have, in this case, we're looking at BeH2. So we can see the pink would be the Be, beryllium, and then the H, or the hydrogen, would be the white. And because of our electrons are separating as far out as they can go, it's going to make that linear shape. Anytime, just like a helpful hint, anytime you see something flat, it's most likely going to be nonpolar. And this is a perfect example of this. These are usually going to be nonpolar, and it is at 180 degrees. Let's look at the next one. This is bent. Now, this really looks like we took linear and we just kind of bent it straight down the middle, and that's pretty much what happened here, okay? So we still have our 2 bonded pairs, but now we have 1 lone pair going on. You can have more than that in a bent molecule, but at least 1 lone pair. And then our bond angle is going to be 120 degrees right here. And they're usually going to be polar because now we are asymmetrical. And a perfect example of this is H2O. And you can see that here we have 2 bonds happening. Those are single bonds. And then we have some lone pairs. And this does make it partially positive and partially negative. And then we have trigonal planar. And trigonal planar is, think of it like flat, okay? Like in math class when we talk about planes, how they're flat. So this one is going to be completely flat, all right? There are 3 bonded pairs now. So 1, 2, and 3. And then no lone pairs. And that's what makes it a planar, flat, okay? 120 degrees in between each one. So they're separating out as far as they can in each direction. It's usually going to be nonpolar because it is symmetrical. And a great example is BF3, and you can see down here the Lewis dot structure, and that it is 120 degrees all around from each bond to the next bond. So if we take that and we kind of bend it again, we end up getting trigonal pyramidal, trigonal pyramidal. And we can see the 3 bonds here, 1, 2, and 3. And we are going to have lone pairs now. So when we have a bend happening, and this kind of looks like a pyramid, right? So when we have the bend happening, we usually end up with lone pairs. This one does have a degree of 109.5. So all the way around, it's roughly 109.5. There are some exceptions, and this is a great one here. This is 107, but notice they're very, very close, you guys. It doesn't have to be perfectly exact. There's always exceptions to the rules. And this one is going to be polar. So, and it's polar because, well, it's asymmetrical. It's bent and it's not symmetrical anymore. NH3 or ammonium is going to be a great example of this. And you can see the lone pairs here. So we have 3 single bonds, and then here is our lone pair at like the top of our pyramid going on. So tetrahedral is going to be our last one, and you can see what tetrahedral looks like. It kind of looks like we took trigonal pyramidal and just stuck one more bond on it. I mean, that's pretty much what it is, right? So we have that 4th bond. This is the only one that has 4 bonds that we're learning, and because of this 4th bond, we kind of replaced the lone pair with a bond. So there's no lone pairs anymore, okay? And we're still at around 109.5 degrees. So nothing really shifted in our degrees from bond to bond. And it's going to be nonpolar because now we've made it symmetrical by adding that 4th bond in there. A great example is CH4, which is methane. And you can see that here with our Lewis dot structure. You can see that here with the model of our molecule as well. So let's see if we can try some of these and see if we can get them right. So you can go ahead and pause your video if you need to and see what kind of molecular geometry this molecule is. All right, let's take a look. This one is definitely going to be trigonal planar. And if this is trigonal planar, is it polar or nonpolar? It is definitely going to be nonpolar because it's symmetrical. Let's try this one. What do you think this one is? And this one is bent. So you can see it's definitely bent there, and it's around that 120 degrees as well. So is this polar or non-polar? And you probably got it right. It is polar. Remember, if it is going to be that straight or flat, it's most likely non-polar. And anything that's kind of bent or at more of an angle, it's going to be polar because it's asymmetrical. All right, try this one out. Okay, and that one is linear. So is it polar or nonpolar? And you probably got this one right. It is nonpolar, making that 180 degree angle. Okay, now we're looking at a Lewis dot structure example instead of just the shape of a molecule. Can you get this one right? And this one is our tetrahedral. And we can tell that because it has 4 bonds going on. It's the only one with 4 bonds. So is this one polar or nonpolar? And it is going to be nonpolar. It is symmetrical, and we can see that it is symmetrical all the way around just by looking at the Lewis structure. So try this one out. What do we think it is? And this one is going to be our trigonal pyramidal. And we can tell that because when it has 3 bonded pairs, these are actually double bonds, right? But on the middle, we have a lone pair, and that's going to be the bend that is happening in our Lewis dot structure. So is this going to be polar or nonpolar? And it is polar, absolutely correct. You guys, I hope this was helpful. Go ahead and subscribe to my channel. Thank you all for watching. Bye, everybody.